Now welcome student. In the period we have to see equation for solute left unextracted after nth extraction. Now before this equation for the solute left unextracted after nth extraction, you must know particularly extraction. As you know, extraction, there are two types of extraction. First one is a simple extraction. What happens in simple extraction? In simple extraction, the total amount of given organic solvent is used in a one step is known as a simple extraction. Means in simple extraction, suppose you want to find out the amount of solute in aqueous layer, then this aqueous layer is allowed to stir with the organic solute, definite quantity of organic solvent, then this aqueous layer which contained that solute which we have to extract is allowed to stir in separating funnel with the total amount of organic solvent. Means in the single step the organic solvent can be used. This is a simple one. But what happens in the multiple extraction? Now you know, in the multiple extraction, what happens in the multiple extraction? In multiple extraction, the organic solvent is used. This organic solvent is used to extract organic substance from aqueous layer. Okay. Now this organic solvent is used in the small installment. Okay, this aqueous layer is taken as it is, but small quantity of organic solvent is taken. It is allowed to stir with this aqueous layer. In this way, by parts this organic solvent is used, and after first extraction, then second extraction, then third extraction, now it will be found that this organic substance extracted by multiple extraction will be more. In this way, this is multiple extraction. Now we have to see the equation of solute left unextracted after nth extraction. Okay. Now for this, let me assume, suppose V ml of aqueous solution is there. Let V ml of aqueous layer is there, or aqueous solution is there. Okay, aqueous solution or aqueous layer is there, and it contains W kg of organic substance. Okay, means this aqueous layer is there. Okay, in this aqueous layer, suppose the quantity is VmL, and in this VmL W kg of solute is there. Okay, this W kg you have to extract. Okay, now for this we have chosen another solvent. This is aqueous layer. Okay, now another solvent. This is organic solvent. Okay, now first step we have to use V1 ml. Okay, this V1 ml is allowed to stir in this aqueous layer in the separating funnel and so on. Now this is first extraction. Now in second extraction, again second V1 ml of organic same substance is solvent is taken, allowed to stir, and in this way the experiment is carried out. After the nth extraction, there is a calculation for the solute left unextracted. Now consider, let V ml of aqueous layer contains W kg of organic substance, and here we have seen V1 each time use, that's why let V1 ml of organic solvent is used in each step of extraction, okay. Now very important these 2 points, okay. Now in the first step, that is first extraction, after this first extraction is carried out. Now what happens in the first extraction? First of all, see the let after first extraction x1 kg of substance left unextracted in aqueous solution. How much? Let x1 kg of substance get unextracted after first step, okay. Now see concentration in aqueous layer, see how much quantity is there? x1, okay, extracted, x1 kg of substance left unextracted. Now how much volume of aqueous layer is there? VML, okay, getting it? It is VML aqueous layer. That's why concentration in aqueous layer will be x1 upon V. Now similarly, concentration in organic solvent or organic layer, see carefully, in organic layer what is there? V1 ml of organic solvent is used in the each step. How much? V1 ml. You know, initially in aqueous layer what is there? W kg of solute is there, okay. W kg में से x1 अनएक्सट्रैक्टेड है, मतलब पहले एक्सट्रैक्शन में बचा कितना? W minus x1. Now how much quantity of organic solvent is taken? V1. That's why weight upon volume is nothing but concentration, okay. Now you get the concentration in both layer, then calculate K according to Nernst distribution law, that is concentration in aqueous layer upon concentration in organic layer, okay. See, concentration in aqueous layer, it will be x1 upon V, okay. Concentration in organic layer will be W minus x1 upon V1, okay. Solve it further, x1 upon V, okay, multiply by V1 upon W minus x1. Simple mathematics, because you know, what do you know? X upon Y upon P upon Q, then mathematically x upon Y into Q upon P, okay. This step known to you, that's why we have written it. Now K into cross multiplication V into W minus x1, that is equals to x1 into V1. Now further solving this, because you want to calculate the x1, that is x1 kg of substance remains unextracted after first extraction, that's why kV into W minus kV into x1, okay, is equals to x1 V1, okay. Now these terms when comes to right side, kV W remains as it is, x1 V1 plus kV into x1. Now x1 common, V1 plus kV. Okay, here x1 get common. Now here kVW. Now what is the value of x1? Now from this x1 is equals to W upon kV into kV plus V1. Okay, this is equation 1. Now see second step, that is second extraction. Now again you have to take next V1 ml of organic solvent. Okay, now in the second extraction is carried out by using V1 ml of fresh organic layer. Okay, now x2 kg be the substance, let x2 kg be substance left after second extraction. Okay, now after this find out the concentration in aqueous layer. Now see concentration in aqueous layer, that is equals to, what is it? See, x2 kg be the substance left after second extraction in aqueous layer. Okay, now again you know the quantity of aqueous layer, how much it is VML. That's why x2 upon V is the concentration in aqueous layer. x2 upon V is the concentration layer in aqueous layer. Now concentration in organic layer or organic solvent, how it is after first extraction? x1 kg be the solute left unextracted. Okay, after second it will be x2 kg remains unextracted. Now concentration in organic layer will be x1 minus x2, but fresh quantity of V1 ml. Okay, then again according to Nernst distribution law, concentration in aqueous layer, that is in water, upon concentration in organic layer, again aqueous layer, x2 upon V. Now multiply and opposite to this, x1 minus x2, simple. Okay, now after solving this, kV into x1 minus x2 is equals to x2 into V1. Now kV x1 minus kV x2, that is equals to x2 V1. Now transfer this term to right side, kV into x1 remains as it is, x2 V1 plus kV x1 kV x2. Okay, now x2 common, it will be kV plus V1, it is kV into x1. Now what is the value of x2? x2 is equals to x1, okay, into kV upon kV plus V1. It is the equation second. Okay, now put value of x1 from equation 1. What is the equation 1? This is the equation 1. But from equation 1, what you know, x1 is equals to W into kV upon kV plus V1. Okay, this is remains same in both case. Now put this here, hence x2 equals to, what is the value of x1? W into kV upon kV plus V1. Okay, now this term remains as it is, kV upon kV plus V1. Okay, now these terms are same, that's why W into kV multiplied by kV square, kV plus V1 multiplied by kV, that's why whole square, that is x2 equals to W. What is the W? You know, W is nothing but the weight of organic substance in VmL of aqueous solution. This W. What is W? W is the weight of organic substance. W kg is the weight of organic substance in VmL of aqueous solution. It is after second extraction. Now here there is a second extraction. Substance remain unextracted x2. Now for nth extraction it will be xn. That's why is this equation becomes kV upon kV plus V1 raised to power n, and this is our required equation. We want this equation, that is equation for solute remains unextracted after nth extraction. Very important. Now see carefully, in this equation you must know concentration is nothing but weight upon volume. Okay, weight upon volume in each case. Now consider, first of all, V1 ml of aqueous layer contains W kg of organic substance. Okay, after first x2 remains unextracted, x1 remains unextracted, W था उसमें का x1 बच गया, मतलब ऑर्गेनिक लेयर में कितना गया? W minus x1. Okay, that's why this one concentration. Now after this first extraction, second extraction is carried out. V1 ml of fresh organic layer is taken. Okay, let x2 kg be the substance after second extraction in aqueous layer. This is important, in aqueous layer. Now that's why concentration पहले एक्सट्रैक्शन के बाद में x1 बचा था, सेकंड के बाद में x2, तो x2 वाले में ऑर्गेनिक लेयर में कितना जाएगा? It will be x1 minus x2. That's why concentration will be x1 minus x2 upon V1, because organic layer is taken in the same installment of V1 ml. Now concentration in aqueous layer will be x2 upon V. Now again aqueous layer upon concentration in aqueous layer upon organic layer. Now solve this. In this way you will get this. Now this x1 is calculated previously, equation 1. Now put its value, then you will get this one. Now for second extraction it will be 2, it will be 2. That's why nth there is will be n, here is also m. Now this is very important to know that it is nothing but the amount of solute left unextracted after nth extraction, where W kg is the amount of solute present in aqueous layer. V1 ml is the amount of organic layer taken in every installment. Okay, now K is distribution coefficient or distribution constant. I think you all getting this. This is very important for problem purpose. Now any difficulty, ask me frankly. Thank you very much.